Good morning, class. We're going to talk about finding ways to find the slope of a line. So there are 4 ways you can find the slope of a given line, and that can be with a graph, a table of values, 2 points on a line, or within an equation, and there are 3 different equations. And so we're going to use this foldable in order to recognize how to find the slope with how to find the slope of a line and M using that. So if you were to lift up your foldable, say we're going to do the first one, and the first one is using a graph. So if I lift up my foldable, I have a graph given here, and so I have 2 points on this graph, and I'm going to label those 2 points. I have one that crosses the x-axis, and I have one that crosses the y-axis. Okay, so try to use definitive points. Try not to use ones that go in between, because we cannot really use those with decimals or fractions. And so this is where you can find the slope of the graph line, and you can use rise over run. This is why I say you want to pick 2 very distinct points. And so from here you're going to use rise over run. Okay, so that is using the slope on the graph using rise over run. So I'm going to rise up to my y-axis. 1, 2, 3, 4, 5, 6. So I rose up 6 and I went over 1, 2, and 3. Okay, so I rose up 6 and I ran 3. Okay, so notice, however, I went 3 over to the right or over to the left, which means that's in the negative direction of x. So this 3 is actually negative, and 6 divided by a negative 3 is a negative 2. And always check your slope to see, is it positive or a negative slope. We can also recognize that if I were to say positive 2, I have to change it to negative because my line is decreasing. And if it is decreasing, I have a negative slope or a negative m. So that is using rise over run to find the slope with a graph. The next thing we can use to find the slope is using a table of values. And you've done this a lot in your homework already. You're going to find the change in the x value in your table and the change in f of x, or otherwise known as y, and your y values. So the difference, or the change between -1 to 2, so to do that, subtract, so you're finding the difference. So make sure you're finding the difference of each one. So from -1 to 2 is -3. And on the other side, you have the difference of -2 to 4 is a -6. If you're not sure where I'm going with this, I put in -1 minus 2 does give me a -3, and a -2 minus 4 does give me a -6. Okay, so I did that. And so finding 2 values on here, I can deduce. Again, you're going to use f of x, or case y, in case that shows up, over x. Okay, this is the change of y over the change in x. And so with that, I'm going to take my -6, that change, all over the change in x, which is a -3, and I get a +2. So it's nice to do one set of values, but why not check the rest of them and see if they work for all? So the difference between 2 to 4, the difference between 2 to 4 is 2, and from 4 to 8 is 4. Okay, and we can do the same thing from 4 to 5. The change is 1. 5 minus 4 is 1, and then to jump from 8 to 10 is 2. So let's check these 2. So let's change that. So I have 4 over 2, and I do get 2. And then this one, I have 2 over 1. 2 over 1 does deduce as 2. Let's check the very last box to see if we still get a consistent rate of change of 2. So from 5 to 8, I get 3. And then from 10 to 16 is 6. And from there, I can do 6 over 3, and I do get 2. So my slope is 2. So I can just from there, the slope is 2 using a table of values. Now we can do slope with 2 points. I'm only given 2 points, and there is a slope formula that can use for those 2 points. This works for rate of change and for slope. And we can use m is equal to y2 minus y1 all over x2 minus x1. And so it helps to label what your x and y's are. What is your x2? What's your y2? So always do that first. So 2 can be your x1, and 5 is your x2, negative 3 is your y1, and negative 6 is your y2. Okay, so now all we have to do is plug in the values. So m is going to equal my x, or my y2, which is negative 6, minus y1, which is negative 3. Okay, no, I put this in parentheses because we want to subtract it, but we want to plug it in for y1, not negative y1. Then we have all this over x2, which is 5, minus x1, which is 2. Okay, so then this changes to a negative 6. You have to keep, you're going to change it to a plus sign. Okay, and then this becomes a positive 3 now. Keep, change, flip. All over 5 minus 2. Okay, and so moving on, I have 6 plus 3. So 6 plus 3 does give me negative 3. And then 5 minus 2 gives me a positive 3. And negative 3 over 3 gives me 1. So m equals 1. That is your slope. So that is using 2 points in order to find your slope. You're going to use the slope formula. Okay? And then the last way, we have 3 different forms using equations. So slope-intercept form is where they give you your slope and your y-intercept. Point-slope form does introduce a point for y and for x, and then you have standard form. And so we're finding the slope here. We know that slope-intercept form is y equals mx plus b. Well, we know that m stands for the slope, and that is the number in front of the x, and so m is negative 2. Okay, so m is negative 2. Now point-slope form point-slope form is y minus y1 equal to m x minus x1. This is where y1 and x1 can be any point. So in this case, we just want the m, and the m is going to be 2 over 3. So we know that 2/3 is our slope there. And then for our last one, standard form, it's kind of hard to deduce the slope from this accurately. So this is where you want to solve for y. So when you have standard form, go ahead and solve for y to make sure you have the accurate slope. So when I do that, I'm going to move my 5x over to the other side. So I'm going to subtract 5x. So now I have negative 12y equal to negative 5x plus 24. Now I'm not done yet because I need to get y by itself. So I'm going to divide everything by negative 12. So then I have y equal to a positive 5 over 12x, and then 24 divided by negative 12 gives me a negative 2. And here our slope is just as defined in slope-intercept form, and that is our 5 over 12. Okay, so that is identifying slope in 3 different equations with slope-intercept form, point-slope form, and standard form. Okay, so remember that slope-intercept form is y equals mx plus b. Okay, our point-slope form is y minus y1, where that's any number, equal to m parentheses x minus x1, where x is a number. And we always want m. Okay, and then standard form, we know that is ax plus by equal to c. However, we want slope to be converted to solve for y, to where it looks like y equals mx plus b. Okay, so those are 4 different ways to find the slope in given scenarios, such as a graph, a table, using 2 points, and with 3 different equations. And that concludes our set of notes. Again, feel free to rewind or pause at any time if you need to write. I do have tutorials on Thursdays from 3 to 5. Thank you so much.